So what we call this is a fractionating column. A pipette or a burette is used to transfer the liquid, but here in because this technique is a fractional distillation, so this is a fractionating column. This one is stand or tripod stand. Label the arrows in the condenser. So these arrows, what are the labels for the arrows in the condenser?
Cold water in, cold water out.
So, or you can basically cold water will enter and it will absorb energy and it will become
Yes,
hot.
hot water out.
Hot water will leave. Identify one mistake in the apparatus. What is a mistake in this apparatus?
Don't give heat to the final product.
Or heat supplied to distillate. The heat is supplied to distillate or heat supplied to a beaker. Which liquid would collect first and explain your answer? We have water, which is boiling point 100, and ethanol, which is having a
Ethanol.
boiling point of.
Ethanol.
So which liquid
It will
will
boil first.
so ethanol will collect ethanol first, and reason why ethanol will be first, because it has low boiling point, so it will vaporize first. Why would it be better to use electrical heater instead of a Bunsen burner? Why electrical heater is useful here?
It will be
Here,
faster, I guess.
no, electrical heaters, because Bunsen burner, the ethanol is a
Yeah,
flammable
flammable.
liquid, so it can catch fire. So ethanol is flammable. As ethanol is flammable, it can catch fire. So for the safety, we can use electrical heater. Not about heat loss or gain, it is about the safety. A student investigated the reaction between the aqueous sodium carbonate and two different hydrochloric acids A and B. Sodium carbonate react with hydrochloric acid, gives sodium chloride plus water plus carbon dioxide. Three experiments were carried out. Experiment 1, using a 25 cm cube of Meijing cylinder, an aqueous sodium carbonate is poured into a conical flask. And in experiment 2, the experiment 1 was repeated with a different indicator. The question is, experiment 1, what is the initial burette reading and final burette reading? What is the initial burette reading in experiment 1? Because the burette is filled up to 0.0 mark. So what is the initial reading? If it is filled with initial, starting. This is a final reading, but we need initial. Initially, the burette is filled up to 0.0 mark. So what is the initial reading of experiment 1? That's 0. Because it is accurate to 0.1 centimeter cube, so you will write 0.0. Instead of only writing 0, write 0.0. The final burette reading. What is the final burette reading? That is 13.2. So initial is 0.0, the final is 13.2. So experiment 1, the difference of the two values is 13.2. In experiment 2, what is the initial reading? A burette reading. Initial burette reading for experiment 2. They did not fill up to 0 mark. Here is 12, 12.1, 2, 3, 12.1, 2, 3, 4, 5. Between 13 and 12, how many lines are there? 1, 2, 3, 4, 5. So each is 0.1. And this is at the 8th line after 12. So that is 12.8. So initial is 12.8. What is the final reading? The final burette reading. 39.2. So what is the difference? 39.2. What is the difference in the two values? 26.4. So what you did, using a 25 cm cube of sodium carbonate was poured into a conical flask. First you fill the burette with solution A, then you fill the burette with solution B. And if you see the question, using a 25 cm cube, sodium carbonate was poured into a conical flask. So sodium carbonate is there in a conical flask. Which will make the solution alkaline. The aqueous sodium carbonate will increase the amount of hydroxide ion. How? Because by accepting a proton, more OH ions will be there. A burette was filled with solution A. So in the beginning, we filled the burette with solution A. And same thing is done. The experiment was repeated. The experiment 2 is repeated using a methyl orange indicator. Instead of the first indicator, and the solution is alkaline, like the color of the methyl orange is given. Methyl orange is red orange in acidic and yellow in alkaline solution. A burette diagram record the reading in the table to complete the table. So in the next part, state the color change was observed in the flask. So initially it was alkaline, and you are adding an acid. So when you are adding an acid, so alkali will be used up. If originally it is alkaline, it will be yellow. But when all of the sodium carbonate used up, the solution will turn acidic. So it will turn into red and orange. So it will turn from, or changes from, in the beginning, because the solution was alkaline, it is yellow in color, and then it will turn orange or red. The next question, experiment 3. Experiment 1 was repeated using solution B of acid instead of solution A. And using a burette diagram, record the reading and complete the table. Initial and the final reading. What is the initial burette reading? 9.9. What is the final burette reading? What is the final burette reading? 16.5. What is the difference? So 6.6 is the difference. So when we take, for experiment 1, when we react sodium carbonate with solution A or acid A, in the here we have 25 cm cube of sodium carbonate, which is 25 cm cube. And for a complete reaction in experiment 1, how much A is required in experiment 1? We need 13.2 cm cube. Another experiment, we repeat the experiment with the same sodium carbonate, but instead of using solution A, we are using solution B. Sodium carbonate is there in the conical flask and same amount of sodium carbonate, that is 25 cm cube. And now a solution B is added, and how much is there? That is 6.6. Which solution is more concentrated, solution A or solution B? Which solution is having a greater concentration to react with sodium, same amount of sodium carbonate? 25 cm cube of sodium carbonate in first experiment and 25 cm cube is there in the second experiment. Which experiment the solution is more concentrated, A or B? Or which solution of the acid is more concentrated? B is the right answer, because you can see, like example, if I say there are say 5 particles of sodium carbonate. So 5 particles of sodium carbonate are reacting with 5 particles of A. But these 5 particles of A are present in 13.2 cm cube. And 5 particles of B are present in 6.6 cm cube. And we have the formula, concentration is particles or moles divided by volume. So if we are using a smaller volume of unknown substance, it means it is having a greater concentration. So if the unknown solution is in the burette, the one which you need a small quantity, that is more concentrated. But if the unknown solution is in a conical flask, for neutralization or reaction, if you need greater volume of known substance from the burette, the solution in the conical flask will have greater concentration. So here the unknown solution is in a burette. So if I say 5 particles of sodium carbonate are reacting with 5 particles of A and 5 particles of B, but those 5 particles of A are present in 13.2 cm cube, compared to B, the 5 particles are there in 6.6 cm cube. So smaller volume is there, it shows that it is having a greater concentration or more particle in a unit volume. Suggests one observation other than the color change that is made when hydrochloric acid added to sodium carbonate. What you will see when acid reacted with carbonate? Fizz, bubbles, effervescence. But here we have, in the question, we have a solution of sodium carbonate rather than solid sodium carbonate. In the beginning, if you check the question, we took, using a measuring cylinder, aqueous sodium carbonate is used. It is aqueous. So if it's aqueous, you don't find solid dissolve. Only bubbles you can mention. Complete the sentences below. Experiment dash need the largest volume of hydrochloric acid to change the color of indicator. Experiment 1 was 13.2. Experiment 2 was 26.4. And experiment 6 is Sorry, experiment 3 is 6.6. So second experiment required the greatest volume of hydrochloric acid. Now, what would be more accurate method to measure the volume of sodium carbonate? So we should use a burette to measure a burette is more accurate. So we should use a burette to measure the volume of sodium carbonate. What would be the effect on the result, if any, if the solution of sodium carbonate were warm before adding hydrochloric acid? But even the reaction is faster, but that does not make difference to the amount or the volume is needed. Like example, see in the first experiment, you took 25 cm cube of the experimental result. So example, I took 25 cm cube of sodium carbonate, and for experiment 1 from the burette I need 13.2 cm cube of hydrochloric acid for this reaction to occur. The amount of HCl which we use, that is 13.2. If I did this experiment at 20 degrees centigrade and I did the same experiment at 40, the amount of sodium hydrochloric acid required to react with this sodium carbonate, will it change? So it won't change, because this is the concentration here is not changing with respect to the temperature. That is why increasing in temperature will affect the rate is different thing, but what will happen here, we don't have two of them mixed together. What we are doing, we heat the mixture, but still we are adding drop by drop or small quantity of hydrochloric acid. So overall result is not affected by change in the temperature. So for titration, even you carry out titration at high temperature or low temperature, it won't affect the result, because the question is, what would be the effect on the result, if any, if the solution of sodium carbonate were warm before adding? So if effect on the result, there is no effect. And what is the reason for that? Because the change in temperature will not change does not affect the concentration, so it will remain same. If it was a formation of the precipitate and two solutions were mixed together, then higher temperature. If two solutions already mixed and we change the temperature, then the precipitate will form faster. But in this case, because we are adding from the burette drop by drop or small quantity, so even if a flask contain a liquid at 20 degree or 30 degree, that will not make the difference to the amount we need from the burette. Determine the ratio of the volume of hydrochloric acid used in experiment 1 and experiment 3. In experiment 1, it was 13.2. And experiment 3, it is 6.6. What is the simplest ratio between them? You divide by the
2 1.
smallest value. So it is 2:1. You divide by smallest value, which is 6.6. So in experiment 1, it was the volume used is twice as compared to experiment 3. You can write a statement, or you can write as a ratio, like experiment 1 to experiment 3, ratio is 2:1. Use your answer to H1. Deduce how the concentration of solution A differ with solution B. So answer of H, which solution is more concentrated of acid?
The first one.
experiment 1, the solution of acid is more concentrated, or experiment 3? Because
One.
in a conical flask, you have same amount. What you're adding from a burette, that is acid. What is there in the conical flask, that is sodium carbonate. From For experiment 1, I need 13.2 cm cube for complete reaction with sodium carbonate. For experiment 3, I need 6.6 cm cube of acid B for a complete reaction. So which acid is more concentrated from the burette which we add?
B, because it's less with the same
So
same reaction.
B, because small amount is needed for a complete reaction.
So there will be more product.
No, not more product. Amount of product is same. Concentration is means number of the particle present in a unit volume. The term concentration, they have the same. Like example, sodium carbonate, there are 5 particles of sodium carbonate in experiment 1 and 5 particles of sodium carbonate in experiment 3. For to react with these 5 particles, I need 13.2 cm cube of acid A. To react with this 5 particle, I need 6.6 cm cube of acid B. So it means acid B has,
So,
like,
sir,
particles are closer to each other, so we need smaller volume, that shows that it is having a higher concentration.
so Mr. More concentration is equal to more product.
No, more concentration does not mean more product. Concentration is moles by volume. They have the same number of the particle, but the number of the particle present in a unit volume is different. There's a, like example,
Okay.
if I say I have two solutions, both contain 5 particles of the reactant, but 5 particles of a reactant in 13.2 cm cube and 5 particles of the reactant in 6.6 cm cube. So their concentrations are different, because here what we have same number of the particle in a large volume of a solution, so less concentrated. Same particles but in a great smaller volume of a solution, so more concentration. But when we react A with another substance and B, like A with sodium carbonate, B with sodium carbonate, both will result in a formation of same amount of the product. The term concentration is used for solution, shows the number of the particles present in a unit volume. Higher concentration does not mean that if volume is kept same, like if I say I have two solutions and they have the same volume. If two solutions having the same volume, then the one which is more concentrated will have more particles, which will result in a formation of greater product. So when you
Okay.
relate the concentration, you have to check both things, whether your change, because the concentration can change with the change in volume, concentration can change with the change in particles or the moles or the molecules. So if you have two solutions of same volume and I say one is more concentrated, so the one which is more concentrated will have more particles, and in that case when it react, it will give greater product. But when two solutions have different volume, the one which is having a larger volume, it means it is having a low concentration if they have equal amount of particles.
So will it affect the rate of reaction?
The concentration affects the rate of reaction. Higher concentration will affect the rate. If the number of the particles are different, then it will affect the amount of product. But if number of the particles are same and the volume of a solution is less, so it will only affect the rate of the reaction, will not affect the amount of product.
Got it, sir.
So use your answer to H1, deduce the concentration. So when, what we can say about the concentration for A, we are using greater double volume as compared to B. So concentration of B, because the relation between concentration and volume are inverse. So when inverse, if one thing is multiplied, the other will be half. or if one thing is divided, the other will be multiplied. So the experiment 3, in which we are using a solution B, the volume is divided by 2. So means the concentration is multiplied by 2. So concentration of B is twice compared to A, or B is more concentrated than A. Then suggest a different method using a standard laboratory chemicals to determine which solution A or B is more concentrated. So another simple experiment which you have to plan and say which is more concentrated. So how you can work out in this case? So you can measure the rate of the reaction, because the one which is having a higher concentration will have a faster rate of the reaction. So what I can do, I can mix two solutions in a conical flask and measure the volume of a gas with respect to time. Like measure the volume of gas in 1 minute. I mix acid A with sodium carbonate instead of adding from the burette. Or in a conical flask, acid B and sodium carbonate. And what I'm doing, I'm collecting the gas given off and measure not the final volume, measuring the total volume of a gas. Sorry, not total volume, measuring the volume of the gas in a specific time interval. Like example, after 2 minutes, after 1 minute, and determine the rate of the reaction. So you need a stopwatch as well. So this is one method. Measure the volume of gas with respect to time to get the rate, and compare the rate. The one which is having a faster rate will have a greater concentration of acid. This is one way. Or what you can do, you can also use electrolysis. You can set up the electrolytic cell, because concentrated solution means they contain more particles in a unit space or volume. Take equal amount of acid A and B, then connect them with the supply, pass the equal same, use the same voltage supply. So we know that solution B is more concentrated than A. So if it is more concentrated, then the lamp will be bright here and the lamp will be dim. Is it clear? When we are passing a current through the solution, the concentrated solution have more ions, more particles. So rate of conduction or conduction rate is much faster, higher as compared to dilute solutions. Is it clear, this part? So any method you can choose. Two substances C and D were analyzed. Solid C was a salt and solution D was an aqueous chromium 3 chloride. Test on solid C. Solid C was added to a distilled water in a test tube and shaken to dissolve. The solution was divided into two portions. The test tube of the following test carried out. Appearance of the solution, it's a colorless solution. So this gives an idea that it does not contain any transition element. The pH of the solution was measured. pH is 7. It means it is making a neutral solution. Dilute nitric acid was added to a second portion, followed by silver nitrate. Aqueous nitrate is a test for chloride, bromide, and iodide. So if it is giving a cream precipitate, what it gives? It shows that it is a bromide ion is there. A flame test is carried out and it is giving a yellow flame. Yellow flame is due to sodium. So what we conclude, what we can say about this, identify solid C. What is solid C? So it is sodium bromide. So you can see some of the salt solutions are also neutral. From pH 7, maybe you think it is water, but it's not always true that pH 7 is only for water. It can be for different salt solution. But some salt solutions are acidic and some salt solutions are alkaline. So salt solution can be acidic, can be alkaline, or it can be neutral. Describe the appearance of solution D. It contains a chromium. So with reference to chromium, what could be the appearance? So it is green. Tests were carried out on solution D. Complete the observation for the test 1, 2, and 3. Test 1. Drops of sodium hydroxide were added to solution D and then excess of sodium hydroxide. So first when we add drops, it will form a green precipitate. But when we add an excess, the precipitate dissolve and it will form green solution, because if green precipitate dissolve, it will form green solution. So green PPT and precipitate dissolve in excess to form green solution. Test 2. Excess of aqueous ammonia is added. If we add aqueous ammonia to a chromium, what is the observation? It will form gray-green precipitate, and precipitate insoluble, does not dissolve in excess for chromium. Precipitate slightly soluble or normally considered as insoluble. Slightly soluble are there, small, very small quantity dissolve. So precipitate insoluble or green precipitate will be there. Dilute nitric acid was added to solution D followed by silver nitrate. And already we know, they mentioned in the beginning of the question, it is chromium chloride. So silver nitrate is a test for chloride ion. So it will give a white PPT. Then chromium 3 is converted into chromium 6, and chromium 6 is hazardous. Suggests one safety precaution using chromium 6. If you are using chromium 6, what should be the safety precaution? Use goggles, wear gloves, use protective clothing, mask, fume cupboard. These are the safety measures when you are handling a toxic chemical. Calcium burned in air to form calcium oxide. The reaction is vigorous. Some of the calcium oxide can be lost as a smoke. Plan an investigation to determine the maximum amount of oxygen that combine to form calcium oxide when 2 grams of calcium granules are burned in air. You are provided with a common lab apparatus and calcium granules. So basically what we need the mass of oxygen that reacted with calcium. So for this purpose, we will take a crucible, a small deep container. Size is small, but it is deep. So, and inside a crucible, first what we will do, we'll take a mass of calcium with a crucible. So calcium is inside in this crucible and with a lid. At the top, it is having a lid which does not allow any material to escape. Then we will supply a heat energy. When we supply a heat energy, the calcium will turn into calcium oxide. But how we are sure that all of the calcium is reacted with calcium oxide? So we will heat till the constant mass. What is the meaning heat till the constant mass? Like example, in the beginning it was 2. After some time, like after 1 minute, you heat it and you measure the mass, it's 2.1. Then you heat it again, its mass is 2.2. Then you heat it again, its mass is 2.3. Then you heat again, but the mass does not change. So when the mass does not change, now you're sure that all of the calcium is reacted with oxygen and turned into calcium oxide. And time to time you should open the lid. Why you should open the lid? So that oxygen can enter the crucible and calcium react with oxygen, gives calcium oxide. Is it clear, the planning of this experiment? So we will measure the mass of calcium with lid, the crucible and lid, and then we will heat it, open the lid, allow the air to enter, and then we will cool down and reweight again, and then repeat the procedure until constant mass or the mass does not change. And how to find the mass of oxygen? Mass of oxygen, because that is the mass of calcium oxide and this is the mass of calcium. So when you take a difference of the two, you will get the mass of oxygen reacted. So measure the mass of calcium with crucible and lid, heat it, open the lid so that you have fresh supply of air or oxygen, then cool down and measure the mass again and repeat the procedure until the mass is not changing. What is the reason why you are repeating until the mass is not changing? To make sure that all of the calcium has reacted and it turned into calcium oxide, and measure the difference between the initial, the starting mass and the final mass to know the mass of oxygen reacted.